Okay, let's unpack this. Imagine a future where cutting-edge AI isn't just, assisting, but truly collaborating with humans in one of the most precise fields imaginable, neurosurgery. It sounds a bit like science fiction, doesn't it?
It really does.
Yet, the foundation for this incredible leap, it isn't some super secret algorithm. It's something seemingly simple, actually, but absolutely vital: structured data.
Right.
So our mission today on the Deep Dive is to explore exactly how this underlying structure, particularly something called Json, becomes the bedrock for building sophisticated AI tools. We're talking tools like an AI co-pilot in neurosurgery. We've been looking at sources that, first explain Json and then make this really compelling argument for why human annotation. It isn't just helpful for AI, it remains genuinely indispensable.
And that's really the core question, isn't it? How do we take a machine, an AI, and give it the kind of intelligence, the nuanced understanding it needs to operate in environments where there's, zero room for error, like an operating room? This isn't about AI replacing human brilliance, not at all. It's about augmenting it. And as you'll see, it all comes back to how we feed that AI information specifically through meticulously structured data.
Okay, so let's dive into that. What is this structured data we keep mentioning? Our main example here is JSON, JavaScript Object Notation.
Right.
It might sound a bit technical, but really, at its heart, it's just an organized way of storing information. Think of it like a universal language for data. It makes it easy for a computer or, even an advanced AI like Google's Gemini to understand it and work with it.
Precisely. Let's say you're labeling parts of a complex brain image for a neurosurgeon. You might just say, okay, the red area is the optic chiasm and the blue area is the pituitary gland.
Yeah.
Now, if you just type that into a regular text file, an AI might read the words, sure, but it wouldn't consistently grasp the link between the color, the image part, and the anatomical name. It wouldn't know how to use that information reliably for something like computer vision, not consistently. But if you wrap that same information in JSON, suddenly it becomes crystal clear. Our source material uses this great analogy. It's like filling out a really precise online form. The keys, things like label or color, they're like the specific questions on the form. And the values, like optic chiasm or red, those are your exact answers. This structure gives the AI crucial context. It knows what optic chiasm refers to, the label for the red part.
So what does this all mean for you, listening in? What's the real-world impact, especially in a field like neurosurgery? What JSON does is it fundamentally changes how AI interacts with information, how it sees it. First, it keeps data incredibly structured, searchable. You're not just looking for keywords anymore. You're looking for specific types of info in specific places. Vital for machine learning.
That's really vital.
Second, it lets the AI read and react to really complex ideas consistently. No ambiguity. And maybe most importantly for a collaborative system like this neurosurgery co-pilot idea, it's easy for both humans and machines to read and edit. It's like a translator.
That's a great way to put it. You've nailed the core benefits. Think of JSON as your cheat sheet. You're using it to give the AI a brain, basically. One well-labeled, precisely structured piece of information at a time. This is how we build that foundational knowledge base. The base that allows for true intelligence, especially in these super specialized domains where that neurosurgical co-pilot needs to be utterly reliable.
Right, so this reliance on JSON, it really shines a light on the transformative power of human annotated data. Because JSON is just the container, right?
Exactly. It's the format.
What you put into it, especially these detailed, annotated image text pairings, that's what turns passive viewing of, say, a diagram into real interactive exploration. And that seems essential for teaching humans, but also for the machine learning models that need to see and understand what they're looking at.
Oh, definitely. And what's really fascinating here is how it enables smarter learning for humans. Think about it. Instead of just reading a paragraph next to a static picture, imagine a medical student actually clicking or pointing to a color-coded bit on a brain image and instantly getting clear, concise explanations pop right up.
Okay.
This isn't just neat tech. It actually mirrors how our brains prefer to learn contextually, visually, especially for really complex stuff like surgical anatomy. It makes learning feel more intuitive, more immediate. It turns a flat image into this dynamic tool, which is also great training data for computer vision models.
And it's not just for human learning, is it? It directly impacts that human-AI collaboration we talked about. By encoding expert human knowledge, that deep understanding into structured data like JSON, you're essentially giving a chatbot or an AI assistant an incredibly detailed, navigable map of, say, the human brain.
Exactly right. And this is such a crucial distinction. The AI is no longer just guessing. It's not trying to figure out what you mean from a mess of text.
Right.
It responds with your intended meaning because it understands the structure of the information you've given it, the specific labels tied to the visual data. So the AI shifts. It goes from being just a fancy search engine to becoming a genuinely guided tutor. It understands the relationships, which is key for computer vision.
Wow. That opens up the possibility for a truly custom tutoring experience then. You could have anyone, a seasoned neurosurgeon brushing up or a first-year med student, show a color-labeled anatomical picture to an AI and have a really rich, tailored conversation based specifically on that visual data. It's like learning on demand, super context-specific.
And this setup is fantastic for teaching and testing. You could hide the labels, ask the learner to guess the structure based on the color.
Okay.
Or flip it around, give them the anatomical name, ask them to find it in the image. And crucially, for educators, you could even track which areas learners ask about most often.
Oh, that's smart.
Yeah, it gives you invaluable feedback. You can see where the common knowledge gaps are, maybe things a machine learning model could even help flag later on.
The scalability here sounds huge, too. Our sources mentioned it's not just for brain anatomy.
Not at all.
This method could change how we learned about histology slides, or identify surgical instruments, understand organ systems in pediatrics, or even map out complex mechanical or biological processes. It feels like a really versatile framework.
It absolutely is. In essence, you're building a conversational textbook.
Yeah.
It's not just static info anymore. It talks back, it guides the learner, it kind of evolves with their curiosity. It really transforms how knowledge, especially visual knowledge for AI, gets passed around and absorbed.
Now, this all sounds incredibly powerful, truly transformative, but I can almost hear a listener thinking, okay, this human annotation sounds like a ton of work. Couldn't a really sophisticated AI just do this itself? Aren't they getting smart enough? What's the critical point there? Why isn't that the case?
That's a vital question. And the answer, based on everything we're seeing, is a clear no. You absolutely need human annotation, even with the smartest AI. Here's the first big reason. AI learns patterns, right? It doesn't inherently understand meaning. Without ground truth provided by humans, it's just guessing. And AI isn't born knowing what a carotid artery or an optic chiasm is in an image. It needs examples, labeled examples. Annotation is how we humans tell the AI precisely. See this specific shape in this context? That's the cella. This other shape, even if it looks similar, that's not.
You have to teach it the labels.
You have to teach it. And our source material highlights this perfectly. Even the really advanced models, like in that AI-assisted anatomy recognition paper, they were trained on 640 images that were manually labeled by experts, not just once, but through multiple rounds to reach consensus.
Wow. Yeah.
They insisted on annotations meeting really high-quality standards. That's not something AI can just bootstrap itself into doing, especially for computer vision where accuracy matters. Without those trusted human-vetted labels, it's just noise to the AI. And in neurosurgery, noise isn't an option.
All right, point taken. AI needs that initial human-labeled data.
Yeah.
But what about after that? Can't it then figure out the meaning from raw, unlabeled data? You hear about unsupervised learning.
Right.
Doesn't that let it become more autonomous eventually?
It's an insightful question. And yes, unsupervised AI, where the machine looks for patterns without explicit labels, it can organize data. It might cluster images that look similar, for instance.
Okay.
But here's the crucial part. It absolutely cannot interpret that data clinically. Will it label those clusters correctly? No. Will it understand the subtle clinical risk tied to certain features? Or spot a tiny bit of pathology that only an expert human eye with years of experience would catch? Definitely not. Think about an MRI scan. A clustering algorithm might group all the bright spots it finds. Okay, fine. But only a neurosurgeon can look at those spots and say, right, this one is a safe entry zone for our procedure, but that one, also bright, but if we go near it, we risk major vessel injury.
That's a huge difference.
It's night and day. AI might detect visual patterns, sure, but human annotators provide the critical context, the clinical meaning, what's safe, what's dangerous, what's a landmark versus just visual noise. That level of judgment, AI doesn't have it on its own. And for a neurosurgical co-pilot, that judgment is everything.
That really drives the point home, especially in a medical context. So how does this reliance on human annotation actually play out in terms of AI performance in the real world, in these medical uses? What's the measurable impact?
Well, the data we have is incredibly clear on this. Even when experts use AI, their performance gets better if the AI was built on high-quality annotations. In that pituitary study we mentioned earlier, the AI did boost recognition accuracy overall from about 70% to nearly 78%. That's significant.
Yeah, it's a good jump.
But, and this is the key point, it only achieved that because the model was trained on those rich, meticulously annotated data sets created by humans. It wasn't the AI figuring it out
I
magic.
needed that human foundation.
Exactly.
Yeah.
And check this out. The impact on training was even more dramatic. Medical students' performance jumped by almost 13%. Some even started performing near expert levels. And again, why? Not because the AI suddenly became a genius teacher on its own. It was because of that expert-labeled foundation under the hood. That foundation enabled the AI to be an incredibly effective teaching tool and, looking ahead, a safer assistive device.
Okay, so it's clear human annotation is critical for the AI. But what about the other side? What's in it for the humans doing the annotating? Beyond just feeding the machine, how does this process benefit us?
That's the fourth crucial argument, and it's really interesting. Annotation isn't just about teaching the AI, it's also teaching us.
Huh, how so?
Well, when you personally sit down and annotate something complex, like a brain scan, you're forced to be incredibly precise. You have to actively identify structures, categorize them, make fine distinctions. That process inherently refines and solidifies your own knowledge.
I can see that. It forces you to focus.
It really does.
Yeah.
And beyond your personal learning, you're creating incredibly valuable, reusable training tools for other learners. You're helping democratize expert knowledge. And ultimately, looking at that neurosurgery co-pilot, you are directly contributing to making those systems safer. Systems that can one day genuinely assist, maybe even provide warnings during surgery. Why? Because you're giving the machine that precise, reliable map based on human expertise. AI just can't do that autonomously. That's human-in-the-loop intelligence. That's the future, really.
This brings us to a really profound realization, I think, about the future of AI, especially in fields like neurosurgery. It kind of flips the common narrative, doesn't it?
It absolutely does, and the core message from our sources frames it so powerfully. We don't annotate because AI is weak. We annotate so AI can become useful.
That's a great line.
It's not about plugging a gap in AI's ability. It's about unlocking its potential. It's about directing it. Think about the analogy they used. A surgical AI without human-guided annotation. It's like a GPS device without a map loaded onto it.
Right.
It might have a beautiful interface, look really slick, but it has absolutely no idea where it's going. It's useless for navigation, looks impressive, does nothing useful.
That analogy is perfect. It completely encapsulates what we're discussing with creating an AI-assisted co-pilot in neurosurgery. It's not just about dumping huge amounts of raw visual data onto a machine and hoping it somehow intuits brain anatomy or figures out safe surgical paths.
Exactly.
It's about meticulously, painstakingly encoding our best human expertise, our nuanced understanding through structured and human annotated data. That becomes the actual fuel for genuinely intelligent, safe, and collaborative AI, especially for complex computer vision and machine learning tasks in medicine.
Precise.
So what we've really explored today shows that the future of advanced AI, and certainly in critical fields like neurosurgery, it isn't about AI replacing humans, not at all. It seems to be about profoundly amplifying human intelligence and capability through this incredibly detailed, structured, human annotated data. It's about that intelligent synergy between us and the machine.
Couldn't have said it better myself. It's a partnership enabled by careful human guidance. And, this principle, it really extends far beyond the operating room, doesn't it? Consider how this whole idea of human-guided data could potentially revolutionize not just surgery, but really any field that requires nuanced understanding, critical judgment, especially fields dealing with complex visual information. So maybe something for you listening to think about. What specific areas in your own work, in your field, could truly benefit from giving AI a clearer, more detailed, human-crafted map? Where could this approach make a real difference?